Okay, let's dive right into this by comparing how your human brain reads a fraction versus how a literal robot, meaning your calculator, reads a straight, linear sequence of numbers when you don't use brackets. When you look at the fraction format over here on the left, your brain instantly automatically sees two distinct separate groups. You see a top group, the numerator, and a bottom group, the denominator. It's intuitive. But if you take that exact same math and type it into your calculator exactly as it sounds out loud, just reading left to right, the robot brain inside that machine sees something completely different. It absolutely does not see groups, it just sees a string of individual disconnected commands. And this fundamental difference in interpretation, honestly, it's the root cause of so many lost marks in math exams. You're doing the right math, but speaking the wrong language to the machine.
Welcome to today's Explainer, where we are going to completely transform your scientific calculator from this mysterious, frustrating magic box into a highly tuned precision instrument. But here's the catch. That instrument requires what we call an educated operator. We've all been there, right? You've spent 10 minutes doing all the hard algebraic heavy lifting on paper, you've got the logic down perfectly, you confidently plug those numbers into your calculator, and it spits out an answer that is just wildly, clearly incorrect. And it's all because of a simple miscommunication between human and machine. Today, we're fixing that permanently. And real quick, before we get into the core strategy, make sure you subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSC to excel in your Cambridge examinations. Hit that button right now so you don't miss out on these weekly strategies. All right, here is our game plan for today. We are going to comprehensively solve these calculator errors step by step, using a very simple, highly effective framework: input, output, and audit. First up, we'll tackle the order of operations. Then we'll look at the safest way to enter standard form. Number 3 is huge: mastering the art of the sanity check. Fourth, we'll learn how to translate your calculator's display back into the real world. And finally, we will conquer the absolute traps that are time and fraction conversions.
Let's move right into section 1, the order of operations, or as we should really call it, the literal robot's rules.
We need to see how the calculator flawlessly but entirely blindly follows mathematical hierarchy during the input phase. Remember what I said earlier, your calculator is a literal robot. It has zero intuition, it cannot guess what you want, it only has rules. And it always, without fail, follows this strict order of operations. First, it works out absolutely anything you've put inside brackets. Then it handles any powers, like squares, cubes, or square roots. Only after that does it move on to multiplication or division. And finally, at the very end of its process, it takes care of any addition or subtraction. This means it does exactly what it's told, not what you meant for it to do. If you want it to prioritize an addition before division, you have to explicitly force its hand by using brackets.
And this example brilliantly illustrates exactly why you must use brackets for fractions. Take a look at this calculation: 9 plus 3 all divided by 4 plus 2. We know the answer is 2, right? Because 9 plus 3 is 12, 4 plus 2 is 6, and 12 divided by 6 is 2. Simple. But if you are rushing in an exam and typing it linearly without brackets as 9 plus 3 divided by 4 plus 2, you are going to trigger a disaster. The literal robot will look at that and say, division comes first. It will divide 3 by 4 to get 0.75, and then it will add the 9 and the 2, leaving you with 11.75. A completely wrong answer, and you lose the mark even though your algebra was perfect. You must package the entire numerator in brackets, hit the divide key, and then package the entire denominator in brackets. That is how you control the machine.
Moving on to section 2, entering standard form, all about achieving that scientific precision.
When we need to input massive astronomical numbers or microscopic tiny decimal numbers without tripping up the robot, we use standard form. But entering these values requires a very specific technique that a lot of students get wrong. You absolutely must use the dedicated EXP key, or on some newer models, it's labeled as the times 10 to the power of x key. These are specialized functions designed specifically by the manufacturers to bind the number into a single unbreakable standard form entity. Now listen closely, because here is a massive trap that catches countless students every single year. Crucially, if your calculator uses an EXP key, do not, I repeat, do not manually type the number 10 as well. The EXP button literally translates to times 10 to the power of. If you type times 10 EXP, you have just accidentally thrown your entire calculation off by a massive power of 10. Let's see this in action.
Look at this complex standard form calculation. We have 7 times 10 to the power of 7 divided by 2 times 10 to the power of -3. Utilizing these dedicated buttons forces the calculator to treat each standard form value as a single combined entity, which saves you from drowning in brackets. You just press 7, then that times 10 to the x key, then 7. Hit your divide button, press 2, hit the times 10 to the x key, then your negative button, and 3. This guarantees the robot processes it cleanly. And hey, speaking of guaranteeing success, stop scrolling for a second. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries just by fixing small errors like this. Join them right now by subscribing and turning on notifications so you never miss a trick.
All right, let's get into Section 3, the art of checking. This is what I call the sanity check, and it's where top-tier students really separate themselves.
We are now transitioning into the audit phase. This is where we learn to stop blindly trusting the glowing numbers flashing on the screen. Seriously, in a high-pressure exam, it is incredibly easy for your finger to slip, to hit the wrong digit, or to miss a closing bracket. You need to establish what I call mental friction. Whenever you hit that equals key, before your pen even touches your exam paper to write that number down, I want you to pause for just 1 second and ask yourself, is this answer actually sensible? Does this output practically make any sense at all based on the numbers I just fed into the machine? Let me show you an incredibly powerful audit tool. It's rounding the inputs to one significant figure for a super quick mental estimation. Look at the complex, nasty calculation we have here. Instead of just typing it and hoping, round it in your head first. 4.65 becomes 5. 5.72 becomes 6. So your top number is roughly 11. On the bottom, 0.651 becomes 0.7, and 12.7 becomes 10, so the bottom is roughly 7. You have 11 divided by 7, which you know is roughly 1.5. Now you type the real thing in. If your mental estimate is 1.5 and your calculator screen says 1.25, you were golden. You know you typed it right. But if your estimate is 1.5 and the screen suddenly screams 150 at you, you instantly know you messed up the brackets or the order of operations, and you need to type it again. It takes 5 seconds and saves entire grades.
Another part of this sanity check is just deeply knowing your basic number facts. For example, if you multiply a number like 40 by 0.5, your result is 20. The number actually gets smaller. Conversely, if you divide 40 by 0.5, the result is 80. Dividing by a number between 0 and 1 should always make your starting number larger. If you know these rules instinctively, they act like an alarm system, immediately revealing button pressing errors. If you divide something by 0.5 and your number shrinks on the screen, you know for a fact you accidentally hit the multiply key.
You can also use inverse operations to firmly audit the literal robot's work. Think of this as reverse engineering your own calculation. If you type 6.9 divided by 75 and the screen gives you 0.092, don't just clear it. Leave that 0.092 on the screen, hit the multiply button, and multiply it by 75. If it takes you right back to your original starting number of 6.9, you have absolute ironclad mathematical proof that your division was executed flawlessly. It's a closed loop of logic.
Next up, Section 4, Interpreting the Display. We are moving into contextual translation.
Here is a fundamental truth you have to accept. Your calculator does not understand human context. It doesn't understand units. It doesn't know if you are calculating the distance between 2 galaxies, the weight of a shipping container, or the cost of a ham sandwich. It just processes raw, naked numbers. Imagine a real-world exam problem. You have $18, and it needs to be shared equally among 10 people. You punch 18 divided by 10 into the machine. Your screen will simply flash up the numbers 1.8.
Now the calculator drops the trailing 0 because, strictly mathematically speaking, 1.8 and 1.80 are exactly the same value. But you, acting as the educated operator, know that human money requires 2 decimal places to represent cents. This forces you to translate that sterile robotic output back into human reality. You cannot write 1.8 on your exam paper for a money question. You will lose the accuracy mark. You must write the $sign, the 1, the point, the 8, and you must add the 0, $1.80.
Now look closely at this second example. If we share that same $18 among 13 people, the calculator spits out a long, messy, recurring decimal, 1.384615, and so on. Again, the machine has absolutely no context. But because you know this is a real-world currency problem, you must take control, step in, and manually round it to 2 decimal places, making it $1.38. The context always dictates your accuracy. As a general rule, if there is absolutely no real-world context given in a standard math problem, you generally default to writing your final answer to 3 significant figures, unless the question specifically tells you otherwise. Let's tackle our final challenge in Section 5, calculating time and fractions. These are advanced conversions, where the calculator can really become your best friend or your worst enemy. Time is particularly tricky because it operates on a base of 60, not base 10 like normal numbers. A classic tragic exam mistake is thinking that 2 hours and 30 minutes translates to 2.3 hours on a calculator. It absolutely does not. It's 2.5 hours. To handle time correctly, you have 2 options. You can manually convert minutes to a decimal by making it a fraction of 60. So for example, 12 minutes is 12 divided by 60, which gets you exactly 0.2 hours. That's the manual way. Alternatively, and this is a pro move, if your calculator has it, utilize the specialized degrees, minutes, and seconds key. It usually looks like a little circle followed by apostrophes. You can literally type 8, hit that special key for hours, type 32, hit that key again for minutes, and press equals to let the machine do the conversion instantly and flawlessly without you ever having to do manual division. Similarly, utilizing the dedicated fraction key, which usually looks like A, B, C, or maybe a little fraction box depending on your brand, ensures the machine automatically handles simplification. If you type in a massive, clunky fraction, just hitting the equals key will automatically reduce it down to its absolute simplest form. It also allows you to easily toggle back and forth between improper fractions and mixed numbers. This is a game changer because it allows you to avoid messy decimal rounding errors entirely. You keep the math exact all the way to the final step. Ultimately, all of this strategy boils down to one undeniable truth. The calculator is only ever as smart as the person pressing the buttons. You can have the most brilliant mathematical reasoning, you can have completely correct algebra written out perfectly on your paper, but it easily becomes the wrong answer if you don't input it correctly with brackets, output it contextually into the real world, and audit it with a simple common sense sanity check. Think about your own habits when you are doing your homework or sitting in a mock exam. What is the most frustrating literal robot mistake you have caught yourself making? Was it a missing bracket? Was it misinterpreting a decimal as minutes? Recognize those bad habits right now. Establish that mental friction and remember to always stay one step ahead of the machine. That is exactly how you become the educated operator. And here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, don't let another exam pass you by without having these strategies in your back pocket. Drop a comment below with your target grade for mathematics and tell me the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.